Jai Hind, my dear students. Rational numbers. Any number that can be expressed in the form p by q, p and q are integers and q not equal to 0 is called a rational number. All natural numbers, all numbers and integers can be written in the form p by q by taking their denominator 1. For example, 7 we can write as 7 by 1. And minus 11 by 1. And 0 by 1. Thus they are all rational numbers. Okay, listen. Is the number 2 by minus 3 is a rational? We know what is rational number. A rational number is defined as a number that can be expressed in the form p by q, where p and q are integers and q not equal to 0. So here 2 by negative 3. See, this is a form of p by q. Here p is equal to 2 and q is equal to minus 3 are both integers. Okay, this is the form of p by q. P is 2 and q is negative 3. 2 and negative 3 are integers. So 2 by minus 3 is a rational number. Then is minus 8 is a rational number? Minus 8 we can write as minus 8 by 1. Okay, this is the form of p by q. Here p is equal to minus 8 and q is equal to 1 are both integers. So rational numbers is of the form p by q, where p and q are integers and q is not equal to 0. Here q equal to 1, not equal to 0. So minus 8 is a rational number. Okay, then is 0 a rational number? See 0. 0 we can write as 0 by 1. This is the form of P by Q. Here P and Q are integers. Here P is equal to 0 and Q is equal to 1. Q is not equal to 0. Therefore, are both integers. Therefore, 0 is a rational number. Okay. Okay, the next topic, rational numbers on a number line. Okay, the next topic, representation of rational numbers on a number line. Draw a number line and represent the following numbers on it. The first rational number is 3 by 4. See, 3 by 4, both numerator and denominator positive. So, this is a positive rational number. To represent 3 by 4 on a number line, first draw a line. Okay, first draw a line. Then choose a point O on it. Okay, choose a point O on it that represents the integer 0. Okay, as we know that 0 is neither positive nor negative. The points, then a convenient point A to the right of 0. Convenient point A to the right of 0. Right portion. This is O, right portion. This is the left portion. The right of the point O to represent 1. That means the distance OA as unit length. Unit length means 1 unit length. Okay. So, the points represent positive rational numbers lie to the right of 0. This is the right portion. This is right portion, right side. Okay. Represent the positive rational number. This is the left side, negative rational number. Then, this is 1 unit. The distance between the 1 unit, take the, see here the denominator is 4. 4 equal parts. So, this is 1, that is 1, 2, 3, 4 as this 1 unit. Okay, 4 equal part. 1, 2, 3, 4. 4 as equal to 1. Okay, then this is in between 0, O and A, 1 unit. The first equal division, this 1 unit divided into 4 equal parts. The first part is 1 by 4. The second part is 2 by 4. This is 3 by 4. This want to represent 3 by 4. This is equal to 4 by 4. 4 by 4 is equal to 1. Okay. Then to represent minus 2 by 5 on the number line. Here listen, the numerator is a negative sign. So that is a negative rational number. So first draw a number line. Then choose a point O. Then this is a negative rational number. Then choose another one point A. That means the distance between A and O and A is 1 unit. Here represent the positive rational numbers, right side of the 0. Then this point O, A. Okay, this 1 unit. Then this is a negative rational number. So we want a negative side of 0, that is the left side. So that take us O dash, A dash. Okay, in between O and O A dash is same as 1 unit. Then change into this is equal to 1 unit, negative sign, so that is equal to the negative 1. Okay, then O and O dash, take this denominator 5 equal parts. 1 equal part, second equal part, third equal part, fourth equal part, this is the fifth equal part. Okay, then take the first equal part is minus 1 by 5. This is minus 2 by 5. Okay, this one to represent minus 2 by 5. Okay, minus 2 by 5. This is minus 3 by 5. Okay, minus 3 by 5. Minus, yes, 4 by 5. This is equal to minus 5 by 5. That is equal to negative 1. Okay, next is represent minus 3 by 5 and 3 by 5 on the number line. That means we represent the negative 3 by 5 and positive 3 by 5 on same number line. So same as draw one number line. Draw a number line. Then take a point O. Then the right side of O, take us another one point A. This means O to A is 1 unit distance. Then that is the positive side. Then we want the negative side also. Negative, we want to represent negative 3 by 5. So O to next point 1 unit, take us left side A dash. O to A dash is negative 1. That means 0 to negative 1, 1 unit. Here 0 to positive 1, 1 unit. Then first represent negative 3 by 5. So the negative side divided into denominator 5 equal parts. 1, 2, 3, 4. The fifth part is equal to negative 1. Okay. Then this is 5 equal parts. The first part is negative 1 by 5. This is negative 2 by 5. Negative 3 by 5. Negative 4 by 5. This is equal to negative 5 by 5. But this is represent. Okay. Minus 3 by 5. Then positive side. Positive side O to A 1 unit distance. So here 5 denominator 3 by 5 we want to represent. Denominator 5. So this 1 unit divided into 5 equal parts. So 1 second equal part, third, fourth and fifth. Okay, fifth here 1. So this is equal 5 equal parts. This is the first part 1 by 5. This is 2 by 5. This is 3 by 5. Okay. Then this is 4 by 5. This is 5 by 5. 5 by 5 is equal to 1. Okay, understood all of you? Here the next topic is comparison of rational numbers. Compare which rational number is greater or smaller. Here the question is which is the greater rational number in each of the following. See the first question, 2 by 3 and 5 by 2. See the both the numerator and denominator positive, so these are the two positive rational numbers. So we know how can we compare two fractions is greater or smaller. We studied in the aerial classes. Same method we can use here. Different denominator. Take the LCM of the denominators. 3 and 2. No common factor. So we can multiply. We get the LCM. So LCM of the denominator 3 into 2 is equal to 6. Then change into the denominator as equal to the LCM multiply by denominator multiply by 2, same 2 was multiplied on the numerator. So we get 4 by 6. Then 5 by 2. 2 change into the LCM 6. Yes, multiplied by 3. This is also 3. So we get 15 by 3, 5 into 3, 15 by 3 into 2, 6. So 4 by 6 and 15 by 6. Which is greater? Yes, 15 by 6 is greater. That means 5 by 2 is greater than 2 by 3. Okay. Then the next question is minus 2 by 6 and minus 4 by 3. See the numerator one negative sign. This is a negative rational number. So the denominators are different. So take the LCM of the denominators. 6 LCM 6 and denominator 6 and 3. So we can divide it. These two numbers divided by, we can divide it by 3. So we get 2 3s are 6 and 1 3 is 3. Okay. So we can write as the LCM is equal to, next we can divide it only 2. 2 times 1 1. Okay. So LCM is equal to 3 into 2 into 1. So we get 6 as the LCM. Then minus 5 by 6 change into as equal to LCM 6 multiply by symbol 1. So minus 5 by 6. Then minus 4 by 3. 3 change into 6 s multiply by 2 equal minus 8 by 6. Okay. So this is equal to minus 8 minus 5 by 6 and minus 8 by 6. Which is greater? Yes, the negative 5 is the greater. So minus 5 by 6 is greater than minus 8 by 6. Minus 5 by 6 the rational number is, yes, minus 5 by 6 is greater than minus 8 by 6 is equal to minus 4 by 3. Then here listen the third question, minus 1 by 4 comma 1 by 4. See the denominator same. So this is negative rational number, positive rational number. So comparing the denominator same, comparing the numerator. Okay, which numerator is greater? That rational number is the greater rational number. So here 1 by minus 1 by 4, denominator same. So minus 1 by 4 and 1 by 4, 1. The numerator 1 is greater positive rational number. This is the positive rational number, negative rational number. So positive rational number is the greater rational number. So 1 by 4 less than, minus 1 by 4 less than 1 by 4. Okay. Positive and negative rational numbers. Rational numbers are classified as positive and negative rational numbers. When the numerator and denominator both are positive integers, it is a positive rational number. When either the numerator or the denominator is a negative integer, it is a negative rational number. For example, 3 by 8. Numerator positive 3, denominator positive 8 is a positive rational number. Whereas minus 8 by 9, numerator is minus 8, denominator is 9, is a negative rational number. The number 0 is neither a positive nor a negative rational number. Okay, next listen. Positive and negative rational number. We know the rational numbers are classified positive rational number and negative rational number. Okay, how can I identify the positive rational number? When the numerator and denominator both positive, we can say that positive rational number. Suppose 2 by 3, 7 by 9, 8 by 25. See, both numerator and denominators are positive. So, these are positive rational number. Then, any numerator or denominator negative sign, negative 2 by 3, See numerator as negative, so that is a negative rational number. Or 7 by minus 9, see the denominator is negative, that is a negative rational number. One more condition, positive rational number. Listen, either the numerator, both the numerator and denominator, minus 2 by minus 3. We can cancel this minus, that become a positive rational number 2 by 3. Okay, both numerator and denominator positive or negative, that is a positive rational number. Okay. Here given the first question, which of these are negative rational number? Negative rational numbers are either numerator or denominator is a negative sign. See, here the numerator is a negative sign, so this is a negative rational number. Okay, then next question, 5 by 7. The numerator positive and the denominator positive. So, when the numerator and the denominator both are positive, that is a positive rational number. Okay, then 3 by minus 5. See, denominator negative sign. So, either numerator or the denominator, here denominator negative sign, so that is a negative rational number. Then the last number is 0. So 0, we know 0 is neither, the number 0 is neither positive nor negative. Okay, neither number 0 is neither a positive or negative. So this is the number 0. The number 0 is neither positive nor a negative rational number. Okay. Equivalent rational numbers. If the numerator and denominator of a rational number are multiplied or divided by non-zero integer, we get a rational number which is said to be equivalent to the given rational number. For example, minus 3 by 7, that is equal. Multiply both numerator and denominator by 2, minus 3 into 2 by 7 into 2 equal minus 6 by 14. So, we say minus 6 by 14 is the equivalent form of minus 3 by 7. Also note that minus 6 by 14, we can divide at both numerator and denominator by 2, we get minus 3 by 7 is an equivalent rational number, minus 6 by 14. Give 4 rational numbers equivalent to. First, minus 2 by 7. We know we can form the equivalent rational number to multiplied or divided by any non-zero integer, both numerator and denominator, we get the equivalent rational number. So here given the number is minus 2 by 7. We know minus 2 by 7. The common factor of 2 and 7 is no common factor. Only 1 as the common factor of 2 and 7. Okay. So we can multiply any non-zero integer, both numerator and denominator. Suppose we multiply 2 on both numerator and denominator, we get 2 on both numerator and denominator. We get the rational number equal to minus 2 into 2 minus 4 by 7 into 2. Yes, 14. This is a equivalent rational number of minus 2 by 7. Multiply one non-zero integer. Which integer here? 2. Okay. Then minus 2 by 7. Multiply both numerator and denominator by another one integer. We can multiply negative number or positive number. Multiply by 3. We get minus 2 into 3 minus 6 by 7 into 3 21. Okay. We want 4 rational number. So again minus 2 by 7 multiply by another non-zero integer. Multiply by 4. We get minus 8 by 4 into 7 into 4 is, yes, 28. Okay. Then minus 2 by 7 into multiply both numerator and denominator by 5. We get minus 2 into 5 is minus 10 by 7 into 5 is 35. So the equivalent rational number of minus 2 by 7 are minus 4 by 14, comma, minus 6 by 21, comma, minus 8 by 28 and minus 10 by 35 are equivalent rational number to minus 2 by 7. Then next number 4 by 9. There no common factor 4 and 9. So we can multiply. If they have a common factor, we can divide it both numerator and denominator by that common factor. Okay. See this 4 by 14. Suppose given 4 by 14, we can divide it 4 and 14. 2 as the common factor. We can divide it by 2. So we get that number is become minus 2 by 7. The equivalent of minus 4 by 14. Here no common factor. So 4 by 9 multiply by a non-zero number. Okay. Multiply by 2. Easy multiplication. 4 into 2 is 8 by 9 into 2 is 18. Okay. Dividing 2 both numerator and denominator, we get this rational number equivalent to 4 by 9. Okay. Then 4 by 9. Yes. Multiply by 3 or any other number. Okay. Into 3 both numerator and denominator, we get 4 into 3 is 12 by 9 into 3 is 27. Then 4 by 9 multiply both numerator and denominator by 4. We get 4 into 4 is 16 by 9 into 4 is 36. Next is 4 by 9 multiply both numerator and denominator by 5. We get 4 into 5 20, 9 into 5 45. So the equivalent rational numbers are 4 by 9 are 8 by 18, 12 by 27, 16 by 36 and 20 by 45. Rational numbers in standard form. A rational number is said to be in the standard form if its denominator is a positive integer and the numerator and denominator have no common factor other than 1. The numbers minus 1 by 3 and 2 by 7 etc. are in standard form. Next topic is rational numbers in standard form. A rational number is said to be a standard form satisfy two conditions. One is its denominator is always positive. And the second condition, the only common divisor both the numerator and the denominator is 1. Okay. So here the first question, standard form of minus 18 by 45. See, minus 18 by 45, denominator is positive. So the first condition okay. But the second condition, the only the common divisor of both the numerator and the denominator is 1. Here 18 and 45 are composite numbers. So they have a common factor. They have a common factors, many common factors. So to reduce it into standard form, find the HCF of these two numbers, 18 numerator and denominator, HCF of numerator and denominator. So HCF we get, you can divide it 18 and 45, common divisor 3. So 6 3s are 18, then 1 3 is 3, 1 balance 15, 5 3s are 50. Again 6 and 15, 3 as the common factor, 2 3s are 6, 5 3s are 15. 2 and 5, no common factors. So the HCF of 18 and 45 equal common factor divides both two numbers, numerator and denominator. 3 and this 3, 3 into 3 equal to 9. 9 as the HCF. Then take this HCF and dividing both numerator and denominator by the HCF 9. Okay. So we get minus 18 divided by 9, we get minus 2 divided by 45 divided by 9. Yes, 5 9s are 45. So by 5. Okay. So minus 2 by 5 as the standard form of minus 18 by 45. Listen, this denominator 5 is a positive number and the only common factor both numerator and denominator are 1. Okay. So this is the standard form of minus 18 by 45. The next number, listen, minus 12 by 18. Here denominator is positive, but this is a composite number. So take the HCF of the numerator and denominator. So HCF of 12 and 18. We can find out that 12 and 18, the common factor 2. 6 2s are 12, 9 2s are 18. Then 6 and 9, the common factor is, yes, 3. 2 3s are 6, 3 3s are 9. 2 and 3, no common factor, only the common factor 1. So, the common factors dividing both numerator and denominator only 2 and 3. So, we can take the HCF of 12 and 18 is 2 into 3. We get 6 as the HCF. Then the next step is dividing both numerator and denominator by the HCF. Okay, 6. So we get minus 12 divided by 6 is minus 2 by 18 divided by 6 is, yes, 3 6 are 18. So minus 2 by 3 as the standard form of minus 12 by 18. Denominator is positive and only the common divisor of both numerator and denominator is 1. Okay, understood all of you? We write the following rational numbers in the simplest form. Simplest form means standard form. Okay, so the first question is minus 8 by 6. 8 by 6, denominator is positive, but 8 and 6 we can write as the common factor. So find the HCF of 6, 8 and numerator 8 and 6. So we get 8, 6, 2 as the common factor, 4 2s are 8, 3 2s are 6. Okay, next, no common factors 4 and 3. So we can take the HCF is equal to 2. Okay, then minus 8 by 6 change into simplest form, dividing both numerator and denominator by the LCM 2. Sorry, HCF 2. So we get minus 8 divided by 2 is minus 4 by 6 divided by 2 is 3. So this is the simplest form or the standard form. So listen, the denominator is positive and the only common divisor both numerator and denominator as 1. Okay. Then the next question is 25 by 45. It's a composite number. So we can find out the HCF of 25 and 45. So we get 25 and 45. 5 was the common factor. 5 5s are 25. 9 5s are 45. 5 and 9, no common factors. So HCF equal to, yes, 5. Okay. Then to change into this as the simplest form or standard form, dividing both numerator and denominator by HCF of the numbers 25 and 45. So 25 divided by 5 is, yes, 5. 45 divided by 5 is 9. So 5 by 9 as the simplest form of 25 and 45. The next question, 44 72. HCF of, ignoring this negative sign, okay, then take the number. HCF of 44 and 72. 44 and 72, we can divide it by 2, 22, 3 2s are 6, 1 balance 12, 6 2s are 12. Then again 2, 11 2s are 22, 18. Then no common factor 11 and 18. So HCF equal to 2 into 2. Okay, equal to 4. So dividing 44 by 72, dividing both numerator and denominator by the HCF 4. So we get minus 44 divided by 4, 11 by 72 divided by 4. 72, 1 4 4, then 3 balance 32, 8 4s are 32. So we get the answer. Simplest form is minus 11 by 80. Okay. Rational numbers between the rational numbers. Let us try to list the natural number between 4 and 7. 5 and 6, the only two natural numbers between 4 and 7. Now let us try to list integers between minus 3 and 2. Minus 2, minus 1, 0 and 1 are the four integers between minus 3 and 2. From these numbers line, we come to know that there are finite number of natural numbers between any two natural numbers. In the same way, there are finite number of integers between any two integers. Let us now to get rational numbers. How many rational numbers between 3 by 8 and 7 by 8? Mark the rational numbers. 1 by 8, 2 by 8, 3 by 8 and so on till 1, that is 8 by 8. In between 3 by 8 and 7 by 8, 4 by 8, 5 by 8, 6 by 8, Is an answer correct? 3 by 8 can be written as 30 by 80, equivalent rational number. So 7 by 8 can also be written as 70 by 80. The numbers 31 by 80, 32 by 80, 33 by 80 till 69 by 80 are also called between 3 by 8 and 7 by 8. Then 3 by 8 and 7 by 8 can also be written as 300 by 800 and 700 by 800. So, the rational numbers between 300 by 800 and 700 by 800 are 301 by 800, 302 by 800, etc. to 629 by 800. Also called between 3 by 8 and 7 by 8. So, we can observe there are uncountable infinite rational number between two rational numbers. Let us understand this concept better. We want one example. Write 5 rational numbers between 3 by 8 and 5 by 8. Let us make equivalent fractions 3 by 8 and 5 by 8. By multiplying the rational numbers by 5. 3 into 5 by 8 into 5 equal 15 by 40. 5 into 5 by 8 into 5 equal 25 by 40. The rational number between 15 by 40 and 25 by 40 can be 16 by 40, 17 by 40, 18 by 40, 19 by 40 and 20 by 40. Or we can reduce this 2 by 5, 17 by 40, 9 by 20, 19 by 20, then 1 by 2 are the rational numbers between 3 by 8 and 5 by 8. Rational numbers between two rational numbers. List 5 rational numbers between -1 and 0. Listen, -1 and 0, we can write the rational number for -1 is equal to -1 by 1 and 0 is 0 by 1. Then find out the 5 rational number between -1 by 1 and 0 by 1. No rational number in between. Okay. So, we want to find out 5 rational number. So, we want to multiply or change into this rational number another equivalent rational number. Multiply 5 rational number. So, multiply 5 or more one number. So, 5 or more one number is take 6. 6 multiplied by both numerator and denominator of this rational number. 0 by 1 into 6 into 6. We get -1 into 6 minus 6 by 6 and 0 into 6 0 by 1 into 6 6. Then minus 6 by 6 and 0 by 6. In between -6 by 6 we can find out the numbers -5 by 6, -4 by 6, -3 by 6, -2 by 6, -1 by 6 and the last number is 0 by 6. See these 1, 2, 3, 4, 5 numbers. Okay. 5 numbers in between, 5 rational numbers between -1 and 0. We can find out the rational numbers in another way. -1 and 0. -1 we can write as -1 by 1 and 0 we can write as 0 by 1. Then change into equivalent rational number. Here 1 5 or 5 rational number. So multiply 5 or more one number. Okay. So here 5 or more number, the next number 5, 6. Here we take. But we can take another one number, multiply by 10. That is very easy to multiplication. Multiply both numerator and denominator by 10. We get minus 1 into 10 by 1 into 10. 0 by 1 into 10 into 10. So we get the equivalent rational number minus 10 by 10 and 0 by 10. Minus 10 by 10 and 0 by 10. We can find out the rational number in between. Minus 10 by 10. Then minus 9 by 10. Minus 8 by 10. Minus 7 by 10. Minus 6 by 10. Minus 5 by 10. Minus 4 by 10. Minus 3 by 10, minus 2 by 10, minus 1 by 10 and 0 by 10. So, in between minus 10 by 10, that is equal to minus 1 by 1. 0 by 10, that is equal to 0 by 1. In between we can find out these numbers, these rational numbers. More than 5 rational numbers. Select any 5 rational number in between. That means infinitely rational number lies between, uncountable rational number lies between two rational numbers. Okay, understood? Okay, listen the next question. Find 5 rational number between minus 2 and minus 1. We know all the integers and all the natural numbers, all numbers are rational numbers. So minus 2 and minus 1 are integers, are rational numbers. We can change into the rational form p by q form minus 2 by 1 and minus 1 by 1. Then we know no rational number lies between minus 2 by 1 and minus 1 by 1. We change into equivalent rational number, we can find out uncountable rational number lies between these two rational number. Okay. Then change into equivalent rational number. Multiply both numerator and denominator by a common number. So here we want 5 rational number. So multiply 5 more than 5 one number. Easy multiplication 10. Multiply both numerator and denominator by 10. Minus 2 by 1 into 10 and minus 1 by 1 multiply both numerator and denominator by 10. So we get minus 20 by 10 and minus 10 by 10. Minus 20 and minus 10 we can find out minus 19 by 20. Sorry, minus 19 by 10, minus 18 by 10, minus 17 by 10, minus 16 by 10, minus 15 by 10, minus 14 by 10, minus 13 by 10, minus 12 by 10, minus 11 by 10. Next number is minus 10 by 10. These are the numbers lies between minus 20 by 10 and minus 10 by 10. We can you can select any 5 rational number lies between these two numbers. Minus 20 by 10, that is equivalent to minus 2. Minus 10 by 10 equivalent to minus 1. Okay, select any 5 rational numbers. Find 5 rational numbers between minus 4 by 5 and minus 2 by 3. Minus 4 by 5 and minus 2 by 3. Listen here, the denominators are different. In this case, we want to change these rational numbers equivalent to another rational number. So we want to find out the LCM of the denominators 5 and 3. So we know the no common factors 5 and 3. So the LCM is 5 into 3, that is equal to 15. Then change into the denominators as equal to the LCM 15. Multiply 5 into 3. Same as multiply the numerator minus 4 into 3. And minus 2 by 3, 3 change into 15 multiplied by 5, both numerator and denominator. Now we get minus 12 by 15 and minus 10 by 15. Minus 10 by 12 by 15 and minus 10 by 15, in between only one rational number, that is in between minus 11 by 15. Here we want to find out the how many rational numbers? 5 rational numbers. So we want to change this rational number equivalent to another one rational number. So change into this rational number, next equivalent rational number. We want to multiply any number on both numerator and denominator. So here multiply by 10. Okay, any number. This 10 is easy multiplication. So I put the multiply 10 on both numerator and denominator. Here minus 10 by 15. Multiply both numerator and denominator by 10. So we get minus 12 into 10 is minus 120 by 150 and minus 100 by 150. So we can find out how many rational number in between. Yes, 18 rational number. Select any 5 rational number. Say minus 119 by 150, minus 118 by 150, minus 117 by 150, minus 116 by 150 and minus 115 by 150. Or we can find out minus 101 by 150, minus 102 by 150. Select your choice any 5 rational number in between. We know 2 rational numbers. We can find out infinitely or uncountable rational number in between 2 rational number, given rational number. Okay. Next question, find 5 rational numbers between minus 1 by 2 and 2 by 3. See, the denominators are different. So, we want to find out the LCM of the denominator 2 and 3. We know 2 and 3 no common factors. So, 2 into 3, 6 as the LCM. Then change into first rational number as equal to the LCM to change into equivalent rational number 6. So multiply both numerator and denominator by 2, change into 6, multiply by 3 on both numerator and denominator. And minus and 2 by 3. 2 by 3, 3 change into 6, multiply by, yes, 2 on both numerator and denominator. So we get minus 3 by 6 and 4 by 6. In between 3 by 6 and 4 by 6, we can find out minus 2 by 6, minus 1 by 6, 0 by 6, 1 by 6, 2 by 6 and 3 by 6. These are the numbers lies between minus 3 by 6 and 4 by 6. You can select here how many numbers? 6 numbers. You can select okay and write any 5 rational number in between minus 1 by 2 and 2 by 3. Okay.